All right, folks, we are going to be going over chemical bonding today. You should have a graphic organizer that kind of breaks it down into three sections: ionic bonds, covalent bonds, and metallic bonds. So that's what we're going to be following today. Ionic bonding is a really common type of bonding, and it's when we have an atom of a nonmetal combining with an atom of a metal. And what they want is to both have 8 valence electrons, or the same number of electrons that a noble gas has. So something like helium or neon or argon. They'll try to get rid or gain valence electrons in order to have that number of electrons. So what happens is the nonmetal wants the electrons. The metal doesn't want the electrons. So what the metal does is said, hey, you can have my electron, I don't want it. And then they both become kind of attracted to each other because one is positive and one is negative. So when we look at this picture here, this is an ionic bond. So yes, this is an ionic bond. And what we have here is a metal, which is magnesium, and a nonmetal, nitrogen. So these numbers down here indicate how many atoms of the metal combine with how many atoms of the nonmetal. So what we're going to see is how these combinations happen. So when we look at a neutral regular atom, the nonmetal's here, the metal's here. The metal has an extra valence electron or an extra 2 valence electrons that it really doesn't want because it wants to be like a noble gas. So this metal here is going to really try to get rid of it. So then what we see happening is the nonmetal really wants a valence electron or 2 valence electrons or 3 valence electrons. So it's going to take those ones that the metal doesn't want. Now when that happens, the metal atom becomes a cation or a positive ion from losing an electron. The nonmetal becomes negative from gaining an electron, so an anion. Then these two are attracted together kind of like two magnets. You have a positive end, negative end, they like to stick together. That's because the metal is positive, the nonmetal is now negative. And when we see an ion, this is any atom that has more or less electrons than normal. So we've already talked about ions. That shouldn't be anything new to you, but if you do need to refresh that, make sure you do so because it's going to become very important for this next unit. And again, this is what we said in a couple slides ago, but metals will tend to lose electrons and become cations, okay? And nonmetals will become anions. What we see as far as properties of ionic compounds, they tend to form crystal structures. So you've seen this before if you've ever seen rock salt. It has a very geometric pattern and very straight edges. That's because it's a crystalline structure. So the ions that are bonded together, since they're positive and negative, they like to kind of stick together in very specific arrangements and everything becomes very organized and very crystalline. The ions are very strongly bonded because they have that electrostatic or that positive and negative attraction. They really don't like to be separated. And the structure is very rigid, so you don't end up getting nice curves or anything like that. What you have are very straight lines, nice geometric angles. And ionic compounds have very high melting points. Because the attraction of those ions is so strong, when you heat it up, they don't like to break apart. They try to stay together as long as they can, and then if you reach something like, 800 degrees Celsius, they crack apart. And you can see here in this picture, we end up seeing this crystalline structure. Now, these negatives and positives got a little messed up. So the yellow should be positive, the purple should be negative. But what we see is everything sort of fitting together nicely because you have the positive that likes to be around all these negatives, and the positive likes to be around these negatives, and vice versa. As far as conducting electricity, ionic compounds by themselves, like a piece of salt, do not conduct electricity. They are insulators. However, if we melt an ionic compound, so if we were able to get, let's say, a salt crystal up to a high enough temperature and it would become a liquid state instead of a solid, then it would conduct electricity. Or if we were to take it, dump it in some water, mix it up, make a solution, that would also conduct electricity. But ionic compounds solely by themselves don't conduct electricity. They have to be melted or they have to be in water. You need to make sure you know this for a quiz because it's going to come up again. So write that somewhere in your notes, star it, highlight it. It's very important. And we talked about them being brittle. When you have a crystal, it won't break nicely. It sort of shears apart. So you have to really have a lot of strength behind it and they'll sort of crack apart in really nice lines. Covalent bonding, ooh, that got kind of ugly. But covalent bonding is when you have a nonmetal and another nonmetal sharing their electrons so they both have that happy number, the same as a a noble gas. So they're going to end up sharing. So like sharing is caring. That's how covalent bonding works. What we have happen is where one nonmetal shares its electron to another nonmetal, and that other nonmetal shares its electron to this nonmetal. So we end up getting this kind of like recurrent swapping of the electrons so that they generally will be happy most of the time. So what you're going to end up seeing, there's going to be a slide next where you'll see here we have two fluorine atoms. They both have 7 electrons, and they really, really, really want 8. So what's going to happen is they're going to get closer together. Look how close they're getting. Boom. Now, if you look here, this fluorine, if we count the electrons surrounding it, has 8. And this one has 8. What's going to happen is these two guys sandwiched in the middle are going to get shared between the 2 atoms. So what we'll see here, that has 8, and that guy has 8. So this sharing process allows atoms that generally can't find a partner as a metal that they can share with a nonmetal. So if we look at, let's say, water's a great example of a covalent compound. If we put one hydrogen with one oxygen, hydrogen's happy because it has 2 electrons, and oxygen still needs 1 more electron. So another hydrogen comes in. Now everybody in this scenario is happy. The oxygen here has 8. These hydrogens have 2, and that's all they want, and these hydrogens have 2, which is all they want. So those are ionic and covalent. Now we're going to talk really quickly about metallic bonds. They're held together. They're not really attracted to their electrons. They don't mind sharing them. So what happens, if you can imagine like a ball pit, this is like a whole bunch of atoms of a metal. They kind of all move around and slide around each other. So their electrons don't really belong to them. They belong to the group. So this is why with metallic bonds, they're really good at conducting electricity. Any metal is conductive. So if you have copper wire, if you have lead, if you have any kind of a pure metal, it's going to want to conduct electricity because you have these atoms and all of their electrons are just sort of floating around and everyone's sharing them equally. Because those electrons are free to move and they're not stuck with one atom or the other, electrons are what allow electricity to move. So because these electrons are free to go wherever, the electricity is free to go wherever. So this is why metals are great conductors. Metals are very malleable and ductile. So what that means, malleable means you can change its shape, you can bend it, and ductile means you can pull it really thin into a wire. So this is where we get copper wires. This is where we get different shaped tools. Metals have been very important to humans forever because of this specific property, malleability and ductility. And malleable means like, oh, I just switched it. I can kind of shift things around without breaking them. And that is about it. So what you need to do, if you didn't get those notes, if I went a little too quickly, that's fine. You can go back, pause it, write what you need, listen to it. You can watch this as many times as you want. That's kind of the nice thing about screencasting. It's sort of up to you how fast or how slow you go. If you have any other questions about the 3 types of bonds, please let me know. We're going to be focusing mainly on ionic bonding first because that's a little bit easier for you to comprehend. And then we're going to move on to covalent bonding in the next unit. So be prepared for ionic bonding to work a lot with chemical formulas, naming compounds, and then doing a lot of labs. We're going to do a lot of labs. So hope you got everything that you needed from this. Let me know if you have any questions. I'll be happy to help.